In this video, we will guide you through building your own DIV network attached storage or NAS from scratch. First, let's define what a NAS is. A network attached storage device is a dedicated file storage system that connects to your existing network. This allows multiple users and devices to access data seamlessly. Think of it as a centralized hub for backing up files, streaming media, or sharing documents at home or in small offices. From a hardware perspective, a NAS is quite similar to a regular PC. It typically includes a processor, RAM, storage drives, and a network interface. You will also find a cooling system, a power supply, and an operating system which is usually Linux-based. If you have these components, you can easily build your own NAS. You can even repurpose an old PC if you have some tech skills. For this build, we are using a modern, compact, and power-efficient single-board computer, the Banana Pi BPI-F3. The Banana Pi BPI-F3 is based on the RISC-V architecture. This makes it an exciting and efficient platform for a custom NAS. It integrates the CPU, RAM, network interface, and multiple I/O ports onto a single compact board. Now, here's the key point: the Banana Pi BPI-F3 doesn't come with built-in SATA ports for connecting hard drives. However, it does feature a PCIe 2-lane M2 key M slot. This slot supports expansion cards like the JMB582 based SATA controller. We are using a PCIe NVMe to SATA adapter with 2 SATA ports, which cost around $7. There are versions with more ports available if you plan to use additional drives. To connect it, simply insert the SATA adapter into the M2 slot. Then, secure it using the included screw. Next, using standard SATA cables, connect your hard drive to the adapter. SATA cables only handle data. They do not supply power to the drives. The Banana Pi does offer one 2-pin and one 4-pin JST-XH power connector. These are suitable for powering either a 2.5-inch or a single 3.5-inch drive. However, if you're using two 3.5-inch drives or planning to expand further, those connectors won't be enough. That's why we are using a 160 watts DC ATX PicoPSU Mini-ITX power supply. This unit conveniently comes with 2 SATA power connectors, making it perfect for powering multiple hard drives. With basic electrical knowledge, you can even expand beyond that. To power the Banana Pi from the same supply, we remove the CPU 8-pin connector, then connected 12-volt DC barrel jack to power the SBC directly. Always make sure to double-check polarity before powering anything. Incorrect connections can permanently damage your components. Once wired, the PicoPSU powers both the Banana Pi and the hard drives using a single power source. The PicoPSU itself needs a stable 12 volts DC input. For that, we are using the MeanWell LRS-100-12 power supply. This unit delivers up to a 102 watt and includes protection against overload, overvoltage, and short circuits. It might seem like overkill, but it's a solid choice for future, especially if you plan to add more hardware later. After confirming everything works, I moved on to building the enclosure. I used MDF boards, measured, marked, and cut them using a jigsaw. Then I assembled them with wood glue, sanded the surface, and gave it a black spray paint finish. It's not perfect, woodworking isn't my specialty, but it gets the job done. During the build, I realized the SATA cable connected to the bottom of the SBC needed extra space, so I made some adjustments post-assembly. Now let's assemble the components inside the case. I mounted the Banana Pi using standoffs I had installed earlier. Since the SATA port is on this underside, I connected the cable before securing the board. Next, I mounted the MeanWell power supply to the base using nuts and bolts. Then I installed an AC power inlet module with a fuse and switch, wiring it properly to the PSU for safe operation. Cooling is essential, so I installed a case fan to exhaust hot air and added ventilation at the bottom to draw in fresh air. A fan controller with a built-in thermostat adjusts the fan speed based on the enclosure's internal temperature, which is placed near the Banana Pi for accurate sensing. For better cable management, I added clips and support brackets inside. Then I secured the PicoPSU and both drives, a 3.5 desktop hard drive and 2.5 laptop hard drive. These are test drives, but if you're building a permanent NAS, I highly recommend NAS-rated drives like the WD Red or Seagate Iron Wolf series for better reliability and lifespan. Initially, I planned to power the Banana Pi using the DC barrel jack, but due to space constraints, I modified the PicoPSU's CPU 8-pin connector to connect directly to the 2-pin header on the board. To turn the system on, I added a latching push button switch wired between the PicoPSU's power on and ground pins. I also connected the 12-volt positive terminal to illuminate the switch when active. With all components installed and connected, including the fan controller to the PicoPSU, we are now ready to move to the software. For the OS, I am using Bianbu NAS OS, a custom distribution available from the Space MIT website and the Banana Pi wiki. It comes pre-installed with OpenMediaVault, which is optimized for NAS environments, so there is no need for manual setup. To install it, flash the image to an SD card using Banana Etcher or a similar tool. Insert the card into the Banana Pi's SD slot. Next, plug in the AC cable and connect your Ethernet cable. You can optionally connect a monitor via HDMI if you wish to see the boot process. Now go ahead and hit the power switch. If everything is working, you will see the Banana Pi logo, the LEDs will blink, and both fans will spin up. I close the enclosure and access OpenMediaVault through the Banana Pi's local IP address. The default username is admin and the password is OpenMediaVault. After logging in, you can format your drives, create file systems, set up shared folders, and configure additional settings just like you would on any other OpenMediaVault system. And that's it, your very own RISC-V powered NAS built from scratch using the Banana Pi BPI-F3. If you're interested in the components I used, I have linked them all in the description below. Thanks for watching. If you found this helpful, give it a thumbs up and consider subscribing for more DIY tech builds.